All right, y'all. Today's lesson is going to be on hypothesis testing with means. This was our first intro into hypothesis testing. So remember, this is where we introduce the HO and the HA. If the P value is greater than 5%, then there is not enough evidence to prove that what we are trying to claim is correct, so we fail to reject. And then if the P is less than 5%, there is enough evidence to prove. So we reject the null hypothesis. In general, the way that we said this was if the P is low, we reject the HO. Okay, so I'm going to go over some key points. I'm going to work 2 model problems, and this shouldn't be too long of a video. So I want you to remember that a type 1 error, like the difference between a type 1 and a type 2 error, a type 1 error is created if you reject the null hypothesis when the null is really true, and a type 2 error is when you fail to reject the HO. Okay, so real world example would be we use the example of jail and being innocent. So we rejected the null when they were really innocent. That would be a type 1 error. And then a type 2 error would be the opposite. If we failed to reject, meaning the person was guilty, but they were actually like walking free. Okay, so let's kind of go down to our steps here. All right, so I taught you to use the 4-box method. So I taught you to name your procedure up here. And then in our boxes, I taught you how to write the conditions, name the parameters, and list your hypotheses. Do some math. We're going to go over today how to not put these formulas because you run the risk of getting them wrong. We want to state the degrees of freedom. We want to draw, and then we want a p-value of this test statistic, and then we want to go ahead and conclude using our p-value. Okay, so let's kind of dive right into some examples. All right, and I'm going to flip back and forth between this screen and the Inspire to just remind you of like how we leverage our Inspire. Okay. The glass used for making windshields is produced using a process called floating, where molten glass is pumped onto a bed of molten tin and cooled rapidly, forming perfectly smooth sheets. The process for producing the sheets is set to result in a mean thickness of 3.18 millimeters to ensure that the sheets of glass are consistent thickness. Every hour, workers randomly select. So this is kind of, They randomly select 10 sheets produced in the packed hour. So if there is convincing evidence that the mean thickness is different from the 3.3 millimeters, the standard deviation is greater than 0.04, the entire process is shut down for recalibration, so it can be assured that the average thickness of the glass sheets is normally distributed. Now this is important because you don't want to stop your production line if you're trying to make something to earn money, because that loses you money. So during 1 hour, the mean thickness of 10 randomly, so if I'm reading this for like some details, my N is going to be equal to 10. My X bar, my mean of my sample, is 13.16, and my standard deviation of my sample is 0.055. So I want to determine whether the mean thickness of the sheets during this hour is different from this friend, and I want to assume all conditions for inference are met. So that was really nice of them to say assume that. So I have one mean, and I want some significant evidence, so that means that I'm going to run a 1 mean t. t-test. Okay, so that's my first step. I'm going to name my test. Now, I am going to, it told me all conditions were met, so I'm just going to put this here to remind myself, and then draw a smiley face, because that was really nice. Okay. Now, for my parameter, the parameter that I'm interested in here, the parameter that I'm interested in here is the mean. It is the true average thickness of sheets during the hour that we ran. Now, for our HO and our HA, we want to go back and look and see what the company is claiming. So the company here is claiming that the mu should be 3.818 millimeters. So here, so the mu should be equal to 3.18, and they stop the production if the mu is not equal to 3.18. So they do not care if it's above or below. It's a problem if it's too big or too small in this situation. So that means that we want to run what we call a two-sided t-test. So now we are going to do the math box. So we're actually going to leverage our calculator and these summary statistics that I came up with. So when we go over here to our Inspire, just going to go ahead and open a new document just to be safe. So I'm going to go to Menu, Statistics. I want to run a stats test, and I have one mean, so I'm going to run a t-test. And I have statistics in this example, so I'm going to hit stats. Now, my mu naught, the mu of my, that they're claiming is 3.18. The x bar, the mean of my sample, is 3.16. The standard deviation of my sample is 0.055. And then I ran a sample with 10. And then you want to be extra mindful and make sure that your alternative hypothesis matches the one that you wrote on your paper, and then hit enter. What's nice about this is it's going to pop out all of the answers that you're interested in. It'll give you your t, your p-val, and your degrees of freedom. All of these need to be listed on your answer so that you get correct points. So let me switch back to that. So here, my degrees of freedom. Ideally, you have this up on your calculator so you can see both at once. So 10 minus 1 gives me 9. The t value that my calculator gave me was negative 1.15. And my p value, I'm going to round, 0.2798. And then remember that you want to compare that p-value to 5%. So as I'm comparing here, I can already tell that I'm going to fail to reject because that's quite a bit larger than 5%. And then finally, I'm going to draw my curve. Now remember, this is a two-sided test. So when you shade on a two-sided test, you're going to want to make sure that you shade on both sides. So my mean was 3.18. I'm a little bit more than 1 standard deviation over here and a little bit more than 1 standard deviation over here. So my represented p-value is shaded on 2 sides, and that is 0.2798. So here we are going, now we want to conclude. So we are going to fail to reject the hoe. There is no significant evidence the mean thickness of the sheets during this hour is different from 3.18 millimeters. Okay, so that's the first one. Let's go ahead and look at the second one. So the second one says a blood sugar level of about 160 milligrams per deciliter of blood 2 hours after eating is a risk factor for gastrointestinal diabetes in pregnant women. At a medical center in Chicago, a study to test the effectiveness of a new drug to control blood sugar level was conducted. 100 women diagnosed with gastrointestinal diabetes were available for the study. 50 women were assigned to 50 women were assigned at random to each of 2 treatment groups. One group received the standard medication and the other received the new drug. So this one is going to be, let's read a little bit more. One group after taking the drug for 3 weeks, 50 subjects who received the standard treatment had a mean decrease. So this is where I'm going to be getting my information from. So the women who took the standard drug, they had a mean decrease in blood sugar of 12 and a standard deviation of 8. The 50 subjects who received the new drug had a mean decrease of 15 and a standard deviation of 9. So we want to know, does the new drug appear to be more effective than the standard treatment in lowering mean blood sugar level? Give appropriate statistical evidence to support your conclusion. Okay, so I have 2 means. I'm comparing them. So that means I am going to run a 2 mean T test. Okay. So now this one I am not off. It didn't tell me that my conditions were met, so I need to check my conditions. So I'm going to draw my boxes here. So it told me that they were randomly assigned. So I'm going to say random assignment given. And I'm going to check that. And then when I check the normality, I want to check 2 things. So my sample size 1 is equal to my sample size 2, and those are both equal to 50. That is greater than or equal to 30. So therefore the CLT applies. Which means I've met my normality condition. Now, if you didn't have more than 30 pieces of data, you would need to look at 2 box plots here, okay, to make sure that it was normal enough with no outliers, okay? Now we want to define the parameters we're interested in here. So here I'm going to say mean. I don't know what it keeps. So mean 1 is going to be the average decrease in blood sugar with the new drug, and mu2 is going to be the average decrease in blood sugar with the old drug. Now, this is where it gets a little bit tricky. The HO and the HA, you need to be really careful when you're defining them. Now, when I'm running a 2 mean, the HO is always the easiest. You want to say that mu1 is equal to mu2. Essentially, there's no difference between the two drugs. Now, for the alternative hypothesis, though, we want the new drug to be more effective than the old drug. Otherwise, we wouldn't push it. So here, that would be mu1 is greater than mu2. Okay. So now, as we're doing this, I want you to be extra careful about what you're typing in the calculator. Okay. So after taking the drug for 3 weeks, the standard treatment, that would be mean 2. So I'm going to kind of organize my stuff real quickly. So let's do this. So x bar 2 is equal to 12 with a standard deviation of x bar 2 equal to 8. And my x bar 1 is equal to 15 with a standard deviation x bar of 9. Okay, so that's what I'm going to go type into my Inspire. So let's go look at it. So menu, statistics, stats test. I'm doing a 2-sample t-test. And here I have statistics again, so I'm going to hit that. So my x bar 1, remember this is the new drug, that had a mean decrease of 15 with a standard deviation of 9. Okay. The standard deviation of 9, and there were 50 people. And then my other one had a mean of 12 with a standard deviation of 8, and I had 50 of them. Now I want to be careful about changing my alternative hypothesis here. My alternative hypothesis was that mu1 was greater than mu2. I'm going to hit enter, and then it's going to spit out all the things. So I can see my p-value, I can see my degrees of freedom. So I am going to go back to my thing. So here, my t-value that I got was 1.76. My p-value was 0.0406, which is less than 5%. So that means my p is low, so I'm going to reject my HO. Okay, my degrees of freedom is 97. We're just going to approximate that, just round. And then I want to draw it. So remember, if your mean is that they're equal to one another, then my mean is 0, and I am almost a full 2 standard deviations away from the mean. So I reject HO. There is significant evidence that the new drug is more effective at lowering blood sugar than the old drug. All right, and that is it. So I will see you tomorrow when we talk about hypothesis test on proportions.